Find the length of the curve AC in feet. In this problem, a sag vertical curve extends from point A to point C. The two tangents of the curve intersect at point B, and the grades of line segment AB and line segment BC are provided. The stationing and elevation of point A and point D are also provided. The problem asks to find the length of the vertical curve AC in feet. The length of a vertical curve equals G2 minus G1 all divided by R, where G2 and G1 refer to the grades, or slopes, of the line segments tangent to the end and beginning of the curve, written as a percentage. The variable R refers to the rate change in slope along the curve and is in units of percent per station. We can determine the value of R from the equation of the curve. Y equals R over 2 times x squared plus G1 times x plus the elevation at the beginning of the vertical curve. If we isolate the variable R, the equation for R becomes R equals 2 over x squared times the quantity y minus G1 times x minus the elevation at the beginning of the vertical curve. In this equation, the variable x refers to the distance from the beginning of the curve to the point of interest on the curve. From the figure, this point of interest is point D, since we have specific data for point D. Therefore, our equation for the distance x is station D minus station A, or 6 plus 0, 0 minus 0 plus 0, 0, which equals 6 plus 0, 0, or 6 stations. Back to our equation for R, the variable y refers to the elevation of a point of interest along the curve, which corresponds to the point at a distance x from the beginning of the curve, which is our point D. G1 refers to the grade of the line tangent to the curve at the beginning of the curve. So G1 is the same as GAB. An elevation BVC refers to the elevation at the beginning of the vertical curve, which is given as the elevation at point A. After plugging in all the appropriate variables, the rate change in slope equals 0.278% per station. Just to clarify the units, when we multiply negative 0.80% by 6 stations, we're really multiplying negative 0.80 divided by 100 times 600 feet. So this part here equals negative 5 feet. Back to our problem, if we plug in 0.278% per station in for variable R, as well as grades A, B, and BC, then the length of the curve computes to 6 plus 48 stations, or 648 feet. When reviewing the possible solutions, the answer is D.